Find the inflection points and concavity for the function f of x equals 3/4 x squared minus 1 to the 2/3 power. All right, so we know for inflection points and for concavity, we need to find the second derivative, right? So let's go ahead and find the first derivative first. So in this case, we can just use the power rule, right? But then we also have to use a chain rule, right? Because essentially we have this composite function. Okay, so first thing we'll bring down to 2/3. So 3/4 times 2/3 gives us 6/12. Okay, which is of course also a half. So we'll just put 1/2 here. And we'll put x squared minus 1. And then 2/3 minus 1 is negative 1/3. Okay, but remember, because this is a composite function, we need to take the derivative of the inner function, right? So the derivative of x squared minus 1 is just 2x. Okay, so in this case, we can simplify the 2 over the 2, right? So we get x times x squared minus 1 to the negative 1/3 power. This is going to be our first derivative. And looks like for the second derivative, we're going to have to use the product rule here. Okay, so for the second derivative, right, just use a product rule. Remember, if we have two functions, f times g, the derivative is going to be f prime times g plus g prime times f, or it doesn't really matter, okay, because addition is commutative. So if we call this, now this f is different than this f, right? So this is just labeling purposes. So the derivative, so f prime, derivative of x is just 1, right? So we get x squared minus 1 to the negative 1/3 plus, in this case, g prime times f. Okay, so we got to find the derivative of the g function, which is this guy right here, right? Once again, using the power rule, we get negative 1/3 x squared minus 1 to the negative 4/3 now, okay, times the derivative of x squared, which is times 2x, and of course still times f, right, which is this guy right here, which is that x term, okay? All right, now in this case, I'm just going to convert this to a positive exponent. So we get 1 over x squared minus 1 to the 1/3 power. And then here, you notice that the x times x gives x squared. So the 2 also. So a negative 2x squared over 3 times x squared minus 1. All of that to the positive 4/3 power. Okay. I guess we can just simplify this, right? Plus that negative, so we'll just write that into a minus right here. And this is our second derivative, okay? Well, how are we going to find our critical numbers, right? So in this case, what I'm going to do is I'm going to get the LCD, okay? So I'm going to get the LC. Now, what you could do is maybe set this equal to 0, add this to one side, maybe cross multiply and get something there, right? But in this case, I want to get the LCD. In this case, the LCD is going to be 3 times x squared minus 1 to the 4/3 power. So that means this guy, right, I need to multiply this by a 3, and then I need to multiply that by x squared minus 1, okay, because this is to the first power, which is 3 over 3, plus that one, which gives the 4/3, right? So I want to multiply the top by that same quantity, okay? Now you notice now I have the same denominator, right? Okay, so I get the, let's see, I'll write it down here. I get 3x squared minus 1 to the 4/3. Okay, and on the numerator, notice what I get. I get 3x squared, okay, minus 3. Okay, so I get 3x squared minus 3 minus 2x squared. That gives me x squared minus 3. Okay, so this here is my second derivative, right? F double prime. Okay. Now, once again, the reason why I put these together was so that I can get one fraction, and now I should be able to get my critical numbers, right? I set the numerator equal to 0 and solve. So x squared minus 3 equals 0. Okay, this was pretty straightforward. X was equal to 3. X equals plus or minus, we're at 3. And then I set the denominator equal to 0 and solve. Now, you notice in this case, the 4/3, I'm going to say doesn't really matter, right? But x squared minus 1, right, equals 0. So x is going to equal plus and minus 1. Okay. Now, once again, you notice that f double prime, right? This is f double prime. F double prime of 1 does not exist, okay? But that's okay, right? Because it still counts, right, as a possible inflection point, okay? When I say possible, what do I mean? Okay, well, we gotta plug these in, right? We gotta find f double prime of these guys, right? We got -3, -1, +1, and positive radical 3. So essentially, we have split this up into 5 intervals. We're gonna pick a test point, right? We're gonna pick a test point in each interval, plug it into the second derivative, and see if our result is positive or negative. All right, so let's see now. Okay, rad3 is about 1.7, or in this case negative 1.7, right? So I don't know, let's try like -4. Okay, here's where we're going to be careful, right? This is -1.7, this is -1, so let's try -1.5. Here we'll try 0, we'll try a positive 1.5, and then here we'll try, I don't know, 10, right? Doesn't really matter. Okay, so what is f double prime of -4 now? I'm not going to use a calculator here, right? I'm just going to plug the -4 in. All right, I get +16 minus 3. I get the +16 minus 1, which is positive here, right? So regardless, I don't even care what the answer is, right? What the number is. All I care is that this answer is going to be positive, okay? Now, what about f double prime of -1.5? Here's where it could be a little bit tricky, right? But -1.5, right? When you square that, you get 2.25, right? So this will be negative, this will be positive. So you get a positive divided by a negative here. Okay, that's going to be a negative result. F double prime of 0. You notice when I plug in a 0 here, the numerator is negative. When I plug in a 0 here, this becomes positive. So that's going to be a negative result. F double prime of 1.5, same thing, right? I'm going to get a negative value in the numerator. This will be positive. That's going to be a negative result. And of course, f double prime of 10. Okay, plug 10 in here, 10 in here. All right, that's going to be 100 minus 97, right? That's a positive number. Here we get 100 minus 1 is 99. Okay, so, you know, raise that to the 4/3 power. It doesn't matter what number it is, right? Positive divided by positive remains positive. Okay. So what can we conclude here, right? Well, here we're going to be concave up. Okay, so concave up from -infinity to -rad3, union radical 3 to infinity. We're going to be concave down from -rad3 to positive rad3. Okay, remember we got a plus, negative, 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 plus. So what does that tell us about points of inflection, right? That's going to be a point of inflection. So this one right here. Notice we do not change signs here. You got to be careful with that. Okay, so that's why we can say that we have a point of inflection at -rad3 and a positive rad3. We're concave up wherever the second derivative is positive, and we're concave down wherever the second derivative is negative.